Steel is an engineering material that finds diverse application in all kinds of products, from aerospace to kitchenwares. It's a term that actually describes an entire family of metal alloys. The basic components of all steel materials are iron and carbon. There are many grades of steel, but most people categorize it into two broad groups: stainless steel and carbon steel. In this video, we will discuss about these two categories and the difference between them. Their essential difference is what gives them their distinct physical characteristics. Though they have the same basic composition of iron and carbon, steel types tend to have a variety of alloying elements. Welcome to James Sword Research Channel. Endeavor to watch till the end for better understanding. And if you find the video useful, like and share the video, subscribe to the channel, and turn on notification for more content. Stainless steel. Stainless steel is a type of steel which have good corrosion resistant due to the addition of chromium and other alloying element. It is a group of corrosion-resistant ferrous alloys containing more than 10.5% chromium and less than 1.2% carbon. The chromium is key. It reacts with oxygen to create a passive layer that prevent oxidation and protect the steel from rusting. Based on microstructure, broadly four major categories of stainless steel are available. They are Austenitic stainless steel, Ferritic stainless steel, Martensitic stainless steel, and Duplex stainless steel. Austenitic stainless steel is the most common form of stainless steel. It has the highest generally corrosion resistance among stainless steel, with low yield strength. It is also the most weldable of the stainless steel, due to its low carbon content. They can be strengthened through cold working. Austenitic stainless steel are not magnetic. They are commonly used in housewares, industrial piping and vessels, construction and architectural facades. It makes up about 2/3 of all stainless steel production. Ferritic stainless steel. A form of stainless steel generally with no nickel. Its magnetic characteristics are due to the characteristic grain structure of alpha iron. Heat treatment cannot be used to harden or strengthen ferritic stainless steel, but they possess better corrosion, heat, and cracking resistance than more common types. They are generally more ductile and formable than austenitic steels. Ferritic stainless steel can be welded. The main problem when welding them is poor heat-affected zone toughness. They can be annealed and cold worked to soften them. They are used in heat transfer equipment, dishwasher, and indoor architecture. Martensitic stainless steel are the least common category of stainless steel. They are magnetic and tend to have lower corrosion resistance than other stainless steel due to its low chromium content. It has high carbon content, up to 2%. The higher carbon content is the primary difference between ferritic and martensitic stainless steel. Due to the high carbon content, it is difficult to weld. The high hardness in the heat-affected zone makes this type very prone to hydrogen cracking. It can be strengthened through heat treatment. They can be used to make cutlery, surgical instrument, and turbine blades. Duplex stainless steel contains a two-phase structure of almost equal proportion of austenite and ferrite. It can have up to twice the strength of austenitic stainless steel, making it both strong and flexible. It also has a high toughness, corrosion resistance, and wear resistance. It is generally as weldable as austenitic, but it has a temperature limit. Used in shipbuilding and petrochemical industries. Advantages of stainless steel: easy to clean and maintain, strong and highly durable, high resistant to corrosion and staining, used for a large variety of applications, environmental friendly and recyclable. Disadvantages of stainless steel: it can be very expensive, susceptible to scratches and dents, can often result in costly waste and rework if not fabricated properly. Carbon steel. Carbon steel is a steel that contains mainly of iron and up to 2.1% carbon. They may contain small amount of other alloying element, but carbon is the primary alloying ingredient. It is an iron-carbon alloy, therefore has far lower chromium content, though susceptible to rust. Unlike stainless steel, carbon steel is often cheaper and has its own varying mechanical properties based on carbon content. Types of carbon steel. Carbon steel is categorized into 3 types. They are: 1. Low carbon steel is a type of steel that has small carbon content, typically in the range of 0.05% to 0.3%. They are also known as mild steel. Because of its reduced carbon content, they are relatively weaker and softer, which makes it more malleable and ductile than other carbon steel types. Low carbon steel is very weldable and inexpensive to produce. It is ideal for application in which precision is paramount due to its heightened flexibility. Common uses of low carbon steel include wire, structural shapes, machine parts, and sheet metals. Medium carbon steel. Medium carbon steel is a type of steel that contains 0.3% to 0.6% carbon content and a manganese content of 0.6% to 1.65%. This makes it more challenging than low carbon steel, but more malleable than high carbon steel. This type of steel provides a good balance between strength and ductility, and it is common in many types of steel parts. It can be heat treated to increase strength. Medium carbon steel is frequently used for axles, gears, shafts, and machine parts. High carbon steel. High carbon steels contain from 0.60% to 1.00% carbon, with manganese content ranging from 0.30% to 0.9%. It is the hardest and toughest carbon steel with high strength, good wear resistance, and low ductility. Common uses include drills, cutting tools, knives, and springs. Advantages of carbon steel: good machinability, less expensive than stainless steel, strong and durable, production cost is relatively low, environmentally friendly and recyclable. Disadvantages of carbon steel: vulnerability to corrosion if exposed to water or air over time. It is brittle, not easily bent or mold into diverse shape. Strong and sometimes difficult to work with. Less attractive appearance compared to stainless steel. In conclusion, choosing between carbon steel and stainless steel for your product or project is a complex decision. It will depend on your product-specific requirements and factors, including material properties, cost, corrosion, and heat resistance. When it comes to fabrication, both carbon steel and stainless steel hardens to construct durable products, can be machined without cracking or chipping, and welded to establish strong joint. If appearance, easy cleaning, or corrosion resistance are important, stainless steel is likely the better option, as chromium gives stainless steel its corrosion-resistant properties, making it ideal for use in various applications exposed to moisture or other corrosive environments. On the other hand, carbon steel relatively high carbon content gives it strength and hardness, making it suitable for various applications requiring high stress and impact. Since carbon steel lacks the chromium content of stainless steel, it does not have the same luster or corrosion resistance. Most carbon steel has a matte finish that is prone to discoloration and staining. Stainless steel, on the other hand, is more burnished and lustrous than carbon steel. Ultimately, while carbon steel and stainless steel may be different, they are not necessarily better than each other. It's all about the application.